Stoichiometry is one of those things that a lot of people have problems with when they're first taking chemistry. It's one of those topics that we invariably spend way too much time covering, and still some people never quite get comfortable with it. But it's important because a lot of things later on build upon stoichiometry. So I thought I would work out a sample stoichiometry problem, put it out there for you in case you need to look at one later, and just maybe remind yourself how to go about approaching it. So the first thing we need to do is just read the question and see what it says. Iron 3 chloride can be made by the reaction of iron with chlorine gas. How much iron in grams will be needed to completely react with 58 grams of chlorine? So I need to go ahead and write this equation, because if this equation is not balanced, I can't use it. So this is a reaction of iron with chlorine gas. So that's Fe plus Cl2, and we are making iron 3 chloride. FeCl3. That's my whole reaction. It's very simple. It's not balanced yet though, so we need to go ahead and take care of that. If I put a 2 here, a 3 here, and a 2 here, I think that has it all balanced out. Next, what is given to me in the problem, and what am I trying to find? I am given 58 grams of Cl2, and I'm trying to find iron also in grams. So this is a mass-to-mass stoichiometry problem, which if you can do mass to mass, all the others should be simple because they're just part of mass to mass. But I'm going to go ahead and start with my 58 grams of Cl2. Now, I like to do it this way because this helps me to visualize it. I put whatever I want to get rid of down here. And I need to turn this in and do something with this. I can't convert directly from grams of chlorine to grams of iron, but I can convert between moles of chlorine and moles of iron. And I certainly know how to get from grams to moles, so I'm going to go ahead and do that. Now at this point, moles this is always going to be 1 pretty much. And for grams, it's going to be the mass from the periodic table. Keep in mind, though, this is not just chlorine. This is chlorine gas, which is Cl2. So chlorine is 35.45, and if I have 2 of them, that is 70.9 grams. If you have your calculator, this would be the time to use it, because 58 divided by 70.9 is 0.818. Like I said, my grams cancel, and this is moles of Cl2. Now I'm going to slide down some here and change colors. Because I'm now going to take my 0.818 moles of Cl2. Since I have moles, I'm going to use a mole ratio to turn it into iron. So down here, Cl2 is up there, Cl2 goes here. I want to find iron, so iron goes here. And the mole ratio is the same as the coefficients. So this is my moles of iron. This is my moles of chlorine. So now I have to take 0.818 and multiply it by 2/3. And that comes out to be 0.545, still in moles, but instead of chlorine, we're now in moles of iron. Okay? Let's scroll down a little more. Change colors one more time. Because now that I have moles of iron, we are real close to being done with this thing. I min moles, I want grams. So I'm going to put grams up top. I want to cancel moles, so I'm going to put moles on the bottom. Like I said, it's usually going to be 1 moles, and the grams, once again, comes from the periodic table. There's only 1 iron, so it's 55.8, let's call it 5 grams. So now, 0.545 times 55.85 is, let's call it 30.4. My moles cancel grams of Fe. And that's it. That's all there is to it. And the great thing about stoichiometry is every single one of these stoichiometry problems works out the same way. So if you could do this stoichiometry problem, as long as you know the steps in order, you can do pretty much any stoichiometry problem that gets thrown at you. So don't get discouraged next time you come across one of these.